In this video lecture, I'm going to discuss one of the deadlock avoidance algorithm, which is called as the banker's algorithm. The two algorithms of deadlock avoidance are a resource allocation graph and the banker's algorithm. Resource allocation graph we have discussed, and there we have seen that when there is a multiple instance of resources, the RAG is unable to handle the deadlock. In that case, banker's algorithm is used. So there are various terms used in banker's algorithm like available vector, the number of resources which are currently available. Then max matrix means what is the maximum resources which a process needs to complete its execution. Then allocation matrix, what is the number of resources which is currently allocated to a process. And need matrix, what is the total number of resources which will be required by a process in the near future. This is one example of the banker's algorithm here. Three process P1, P2, P3 is given and maximum resources which the process needs to complete its execution will be given, and the number of resources which are allocated to a process P1, P2, P3 will also be given. What we have to find? We have to find the need matrix. And need matrix is always equal to maximum resource which is allocated to a process minus allocation. Maximum resources minus allocation of resources. Max minus allocation. So we will calculate the need for process P1, P2, P3 as maximum requirement of a process P1 is 3 and its need allocated is 2. So need will be 3 minus 2, that is 1. Same way for resource R2, maximum is requirement is 2 but allocated is 2, so it does not need anymore. So 2 minus 2 is 0. In this way we will calculate the need matrix for process P1, P2 and P3 of resources R1, R2 and R3, R4. Now available resources will be given. What is the total number of resources which are available? So it is given in this table. Now we have to calculate the from we have to calculate the number of resources which are allocated. So we will sum all this summation of all these resources, which is coming 3, and then summation of these resources R2, which is coming also 3, R3 is 5, R4 is 5. Now the resources which is left over is the available resources, which will be my 5456 minus 3355. So it will come resource R1, it will come 2101. So this 2101 resources which are left over is satisfying which process needs. It is satisfying the need of process P1 because the resource need of this process P2 of R3 is 2, but the available is just 0. So it cannot be satisfied. Same way process P3 R3 requirement is 2, but available is 0. So it cannot be satisfied. So only process P1 requirement is satisfied. But it is an unsafe state. How? Because after satisfying the need of process P1, it will terminate and it will release all its maximum resources. What is the maximum resources of process P1? 3211. So it will release this resource. And this resource, after releasing, it will be added to the leftover available resource. So leftover available resource will be calculated as 2101. This resource minus the need which are allocated. Need is 1001. So after subtracting, we are getting 1100. This will be added with the maximum resources which are released by the process P1. Then we are getting 4311, but this is an unsafe state. It will not fulfill the need of process P2 and P3. Why? Because the need for process P2 for resource R3 is 2, and same way process P3 is the need for resource R3 is 2, but the available is only R3 resource available is only 1, so it cannot be satisfied. So this is an unsafe state of deadlock avoidance algorithm called banker's algorithm. There is a chance that there will be a deadlock over here. So this is about unsafe state of banker's algorithm. So if you have liked the content, understood the content, then do like, share and subscribe my channel and do comment also. Thank you.